Hi, I'm Tory Bruno. I've been a rocket scientist for 40 years, and I got to tell you that every single day has been an adventure. I have gotten the opportunity to do just amazing things. I have slept on a torpedo. I have shot a bullet out of the sky with another bullet. I have stood in the middle of Armageddon with all of its terrifying and awesome power. But I have also sent a spacecraft into orbit around the sun, the fastest human object in the universe, flying directly through the literal atmosphere of the sun. There is no career like a career spent in service to this great nation, service to the awesome cause of exploration, and service to the great calling of human dignity around this planet. And now, on the burn sequence, I'm going to pull that curtain back a little bit and let you look inside. So welcome to our show, and welcome to the burn sequence. I have a really fun guest today, and we're going to talk about, natural resources in space. And the way I think about this is sort of through this wonderful home that we live on, the Earth, for which we are the custodians, and we work very hard to, do a good job taking care of this planet. And sustainability is something we think about all the time. But another way to look at that is there's kind of a dark side to sustainability, because in the absence of anything else, we're working on stretching our finite resources, really living smaller and smaller lives relative to those resources and things like energy consumption. But with nothing else, inevitably, eventually, we're going to run out and civilization collapses, which is a pretty dark future. And yet, here we are, in just a scant week travel away from where we're sitting in our very rooms right now is an abundance of natural resources that literally defies human imagination. On the moon and beyond the moon to the near-Earth objects. Tremendous quantities of industrial metals and rare earth metals, water, which is rocket fuel that makes the whole thing work, all of that right there. And so today we're going to talk about that, and I have a really fun and interesting guy who knows a lot about it, Rob Meyerson, a good friend, a great scientist, really also a gifted leader. I first met Rob when he was running Blue Origin, taking it from sort of a research kind of environment to something that was really going to build engines and rockets and start doing really interesting things. And Rob and I, really put together that partnership between ULA and Blue Origin for the engines that power our mighty first stage of the Vulcan rocket. And he is now the co-founder and CEO of Interloon, which really is kind of positioning to be one of the first, if not the first companies that is developing and using natural resources from space. And so, Rob, welcome to the burn sequence.
Well, thank you, Tory. It's a pleasure to be here, and it's very fond memories of that first meeting we had announcing the deal between Blue Origin and ULA, and I was excited to see the news last week where the 30th engine was delivered and 15 ship sets. That's a huge milestone. So congratulations to you and the Blue Origin team.
Oh, well, thank you. And, none of this would be possible without those first things we did together. I'll share with our listeners that we needed a new engine, and we went out looking for one, and we talked to everybody on the planet, Rob. Anybody who had a sketch of an engine on the back of a napkin got talked to, okay? And so it was a very wide net, and we were open to, different propellants, continuing with kerosene, moving to methane, which is the Blue Origin engine. I even talked to a company in Ukraine that, sadly is on the wrong side of the disputed territory right now with Russia. So certainly fortunate we didn't go with that option. But when we finally got to, spending time with you and your team, it was clear that that was the right path and that our cultures were going to mesh well and all this would happen. And of course, you were still developing the engine and you adjusted, the target performance from it for it so it would work for both of us. And it was a big job, and it took a while to get through development, but we got it, and it's a wonderful engine now, and we've flown it several times, and we just love it.
Yeah.
So,
Glad,
thank you for your leadership at the beginning.
Thank you, Troy. Yep.
All right, so when we get our first asteroid mine going, is that going to be an interlunar activity?
Well, first off, we like to call it, it's easy to call this mining, extracting resources from other planets. We're focused on the moon. The moon is a few days away, as you pointed out, 4 days away. And we think the moon is our kind of obvious first step for harvesting resources from space, which is what we refer to it as, because the moon is for all of us, and we want maybe we want to think about this as something that's sustainable to serve humanity on Earth and in space and on other planets for thousands or even more years from now. So harvesting is what we refer to it as, and we are clearly excited about taking that first step to harvest resources from space, starting with the moon and then going to asteroids and on to Mars and other planets.
Pretty exciting future. So when you think about the moon, then Rob, what do you think about first? Is it the water for propellant? Is it helium-3? Is it is it industrial metals? Where do we start?
Yeah, well, we started with putting a team of smart people together, and that team started with Harrison Schmitt, who's the only geologist to walk on the moon. Harrison, as you know, he goes by Jack, flew to the moon on Apollo 17. He trained all of the Apollo astronauts in field geology, and he and I decided to co-found the company about 5 years ago. We incorporated with Indra Hornsby, my COO, with Gary Lai, our CTO and the former chief architect at Blue Origin, and James Antifave, who's our head of product. We looked at everything that's out there, and you mentioned some of them: rare earths, water to make rocket propellant, and we zeroed in on helium-3 because helium-3 is number one. It's the one resource in the universe that's priced high enough to warrant going to space and bringing it back to Earth to sell right now. It sells for $20 million a kilogram.
Oh my gosh.
Commercial market price. We have announced some big sales, including most recently to Blue Forest, which is the world leader in cryogenic refrigeration for quantum computing. The big use case for helium-3 is quantum computing right now, and it's been used historically for border security, for neutron detection. And of course, there's the big idea in the future is that helium-3 will be used for fusion energy. And certainly that's a growth market for us, but not at $20 million a kilogram. You'd have to scale, and you'd have to lower the price of that helium-3 to something more comparable to compete with coal and oil-fired power plants, and $20 million a kilogram wouldn't get you there. But for quantum computing, which is a national security imperative, it's critically important. It's a growth area. And so we've really focused in on that, and gotten a lot of customer interest, and so that's what we focused in on, and we are ready to go get it.
Well, that's pretty exciting stuff, and I'll just take a minute for our listeners who might not be as familiar with it. It's a stable isotope. Mm-hmm. It is used in cooling, a special kind of cooling cycle for. You talked about quantum computing that can reach really, really, near absolute zero temperatures, and kind of a cool thermodynamic process. I'm going to geek out as a mechanical engineer for a minute with you, so forgive me. But, we think of refrigeration cycles with state changes, and then, we always think about vaporizing a working fluid, so going between a liquid and a fluid state. But with, a mixture of common helium, helium-4 and helium-3, there's a phase between a mixture like that where they separate into different concentrations. It's a phase change also, and it has the same kind of sympathetic heat transfer that occurs in any other state change. But in this case, it's really neat because, we're talking temperatures that are like millikelvin potentially. And for folks who are not as familiar with quantum computing, any little thing, any little interaction with the qubits ruins them. They collapse to a state. And so you not only have to isolate them electrically, you have to keep them in the dark. You don't want photons bombarding them, and you certainly don't want thermal energy getting in there. So everything has to be super cooled and, coated in gold, and it's a very exotic application with tremendous potential. The organizing and searching of unstructured databases, the breaking of hard encryptions. It is an active activity that right now has tremendous value to the government and to industrial applications. And helium-3 is just so rare here on Earth. I did not realize the going price was $20 million per kilogram. And yet it's just kind of laying around on the surface of the moon, isn't it?
Yeah. That's thanks for that background. And the helium-3 is made naturally in the sun. So the sun creates helium-3 and other helium-4 also, hydrogen, and it is transported through space via the solar wind. So the moon's been bombarded with solar wind for billions of years. As the moon's surface, its sandy regolith gets churned up with micrometeorite impacts over billions of years. That helium-3 and all the solar wind is distributed down to depth. We have a magnetosphere on Earth, so we don't get that solar wind implantation here. So the helium-3 on Earth is from two sources. One is from tritium decay. We make tritium for our nuclear weapons stockpile. We also make it as a byproduct of certain types of heavy water fission reactors, a couple that are in Canada. And that tritium has a 12.3-year half-life. So it decays to helium-3. And so over the last decades, as we maintain the nuclear stockpile, that tritium we need for the nuclear weapons is decaying, and it's siphoned off, stored in a stockpile. It's stable, and you replace it with new tritium. The second source of tritium is from the creation of the Earth. These primordial trace amounts, or second source of helium-3, is from the creation of the Earth. And in the helium supply we have on Earth, there's about 200 parts per billion of helium-3. And so if you could get it out economically, it could be used and it could be sold for that market price. But there is so much, if we've estimated if you were to capture every molecule of helium-3 from the helium that's extracted from the Earth every year, you might double the current production from tritium decay, which is a handful of kilograms per year. So, what our friends in the quantum industry are projecting is that you would need about 1 kilogram of helium-3 for a quantum supremacy, a million qubit quantum computer in the future, which could be 5 years away, it could be 10 or 15 years away, but it's coming. And we don't have enough helium-3 to support that future demand.
So that would literally be the gating resource for quantum computing once it becomes more common.
For superconducting quantum computing, that's true.
Yeah.
And there are other types of quantum computers, but there's no clear winner. The superconducting archetype, which requires millikelvin temperatures, as you described earlier, is the one under development by companies we're very familiar with. IBM, Google, Amazon, Microsoft all have in-house teams working on superconducting quantum computing, and that's where they're placing their bet. And we're excited to support them and many others.
Yeah, I've heard of those guys. I've heard they've got a little bit of investment resources available for this problem.
They absolutely do, and there is a lot. The state of New Mexico recently placed a big bet on quantum computing, and we're seeing it all around the country right now. So.
Yeah, so there's clearly a market there. We just got to figure out how to get access to it.
Yep.
And, the moon's right there, and there's a lot of it present. Yep. Maybe as we look past quantum computing to an application that's a little bit further down the road, maybe you want to talk about aneutronic fusion with helium-3.
Sure. Yeah. Most of the companies you hear about are producing fusion machines that use deuterium and tritium. And as I mentioned earlier, that tritium is unstable and it decays to helium
Yeah.
three. So there's as rare as helium three is. Tritium is also quite rare. It's radioactive. It's hard to make. You make it in a nuclear reactor. And there is folks in the government I've heard say it's very easy to make more tritium. We can make more helium three by just producing more tritium. Easy is relative, Launching a rocket's easy too, right, Tori? Um,
Yes,
and so
relatively.
yeah, so making the materials that need to be irradiated to make the tritium, it's toxic, it's expensive. Billions have been spent. It takes many years, and then you wait 12.3 years for that tritium to decay to helium three. So
Yeah.
it's a timeline. I think you know going to the moon is equivalent. And the key point I want to make is that like there's been so much investments in new rockets and new lunar landers and new lunar rovers for the Artemis program. We're on the verge of this new era of this new great new industrial base for getting to the moon, getting to space, and that's what excites me most. Interloon kind of brings this one business case that makes sense, at least makes sense to me and to our customers. There's going to be other business cases as well, but once that infrastructure is in place, we can start to utilize it, and that's that is what enables us to get to the moon. And then this race we have, with China, as long as China is talking about going to the moon, which they are, they're doing, they're going to the moon. They've been to the moon 3 or 4 times in the last few years. They're planning to go next year. They're planning to go in 2028, then do ISRU, resource extraction. The Chinese space program is methodical, executing at a very, very high rate of,
Yeah.
and if we're not, if we don't act, if the companies being funded by the Artemis program aren't successful, if the Artemis program isn't successful, we risk ceding the moon to another country and not having access, freedom to operate businesses like Interloon and others. So it is a national imperative as well that we go out and do this.
Yeah, I agree. And I'm a big fan of your business model. I see the availability and access to helium-3 in the same way. I have more than a little bit of experience in handling tritium in the application you referred to. And
Mm-hmm.
The people who say, oh, well, that's the easier path,
Yeah,
I don't think they've thought through that or have that direct experience. It is
yeah,
not an easy path.
right.
And 12 years is forever, especially not just, say, the race to the moon, but we are also in a race with China relative to artificial intelligence and quantum computing, a country that is proving not to be our friend. So this is a pure competition now. And if we're going to make sure these resources are open to everyone and that they are supporting societies that are free and open, then we need to be there and we need to share in it,
Mm-hmm.
because it is for everyone.
People say it's easy to make more tritium. They also say it's easy to go buy more helium-3 from the Canadians. And the Canadians have these CANDU reactors that produce tritium as a byproduct. And that tritium it's a waste. It's been decaying to helium-3. So there is a company in France you've heard of called Air Liquide that has a deal to sell that helium-3 out into the market. The Chinese can buy from them, just as
Sure.
easily as we can. So what we need in the U.S. is a domestic source of helium-3 because we need to
Right.
control our destiny. And what we did 40 years ago, a series of unfortunate events that led to the mess we're in with rare earth elements today in the U.S., is we don't
Yes.
control our destiny in rare earth elements. We might find a new mine to mine rare earths, but we don't have the capability in the U.S. to process those rare earths. So, and we really need, there's great progress, and I'm seeing indications that is being taken, very, very seriously right now, and we're making efforts to turn that around. But we have an opportunity to avoid those pitfalls with helium-3, and do that in the right way by developing the capabilities we're talking about at Interland. I
That
think.
is such a great point. Yeah, I'm glad you brought that up. And just to put in perspective for people, global trade is a great thing. It brings wealth to everyone who participates, and I'm a big supporter. Having said that, critical capabilities and resources that are tied to your country's destiny, its security, its ability to provide for its citizens must be domestic as well.
Mm-hmm.
And we have ceded a lot of our manufacturing capability, for example, natural resource capabilities, to a country that's turning out not to be super friendly and kind of in competition with us. And this would be just another
Exactly.
situation. And you're so right. We're at the beginning of it. We have an opportunity to get in front of it, and
Mm-hmm.
we need to.
Yeah.
So, the business cases there must be one or two maybe engineering challenges that we got to overcome. What do you think?
Of course, of course there are. So first, we got to get to the moon, and like I mentioned, there's 5 years ago there were 0 companies in the U.S. building lunar landers, and now there's at least 6, 7, maybe 8.
Mhm.
Internationally, there's others. The Indians went to the moon. The Japanese have built landers.
Yeah.
Israelis have built landers, and of course the Chinese. The Because there are other companies that we're counting on to get us to the moon, to the surface, and other companies building rovers that we're counting on as well. That allows us to focus on 4 critical areas of technology, and one of them is excavation. So the helium-3 in the regolith is measured anywhere from 2 to 15 parts per billion in the Apollo samples.
Mhm.
We've identified areas on the moon that are likely going to have higher concentrations, but still parts per billion. So we need to be great at high volume continuous excavation. So we've dedicated a team to working excavation. We partnered with a company called Vermeer, and Vermeer is a large privately held company in Pella, Iowa, that makes agriculture and mining equipment. They're a company you've never heard of until you start seeing, you've heard of them and then you see their machines all the time.
Yeah.
They invented the round hay baler. Vermeer, they build horizontal drilling equipment for utility installation. Excavation is their expertise. Their CEO is the grandson of the founder. Jason Anderga is the current CEO. He's become a really, really important partner to us, and Vermeer is working with us hand in hand on excavation. So they bring Earth-based heavy equipment development, and we bring the lunar experience, extreme environment experience, and we're working together with them. The second area of our core technology is sorting. To get the solar wind implanted volatiles out, you want to separate out the rocks from the
Right.
sandy, from the fine regolith. We've developed a size sorting machine that we've tested on Earth. We've tested in lunar gravity. We've tested in zero gravity, and we're getting ready to advance that to the next stage. A little detour. To test lunar systems on Earth, you need a good regolith simulant.
Right.
And those simulants are usually made by universities, Colorado School of Mines, or
Yep.
some companies out there like Icon and Off Planet Resources. Um, uh, you need lunar gravity. So you need an airplane that flies parabolas to simulate lunar gravity. And then you need a vacuum. And better if you can test all 3 at once, but sometimes you have to break it up because, in these tough jobs that we typically do, you have to do your best to simulate, and then you get into the environment. You get to the moon. So we've tested that size sorting machine. The next core part of the technology is the extraction. How do we get the solar wind implanted volatiles out of that sandy fine regolith? And we know a little bit about the science and how how it is implanted in the regolith, and we've decided to go with a mechanical approach. Most ISRU is thermal, and we've hypothesized that if we can get this out using mechanical methods, we'll use about 10 times less energy. And since we've got to bring our utility with us to the surface of the moon, this is a better go-to-market than using thermal. Now, with Secretary Duffy's recent decision to build a fission, nuclear reactor on the south pole of the moon by 2030, that's got us thinking about our architecture. But for right now, this mechanical approach is really important for our go-to-market. And then the fourth part of it is cryogenic distillation. So as you, well, we didn't talk about this yet. Liquid helium's at 4 Kelvin. Helium-3, if you can chill that liquid gas column down below about 1.5 Kelvin or so, you'll have helium-3 left. It's pretty hard to do, pretty energy intensive. We've come up with a way to do that. We've been testing that out in our facility here in Seattle. I think we believe what we've been demonstrating has never been done before. We've never seen it talked about before, and we've actually enriched helium-3 from very, very low concentration up to about 99%. So,
no kidding.
Yeah. So,
wow, I didn't know you had done that.
Yeah.
Have you guys been publishing, or are we like breaking news here?
We're breaking news here. The interesting thing about that is that opens up the opportunity to do terrestrial separation. So that small amount of helium-3 that's in our terrestrial gas supply, we can go after that with our cryogenic distillation approach. And we've been working on that, and we've got some announcements coming, but we're very, very excited about it. And it won't solve the market demand for helium-3 with terrestrial alone, but it does get us into the supply chain and allows us to serve customers sooner before we get to the moon. And that's important.
So for the nation, maybe this is a bridging technology until we can tap the bigger resources out there.
We think so. We think it can be a really important step.
That's really exciting. Yeah. Well, thanks for sharing that.
Of course, Corey. I'm happy to share with you and your listeners. So,
oh, well, super cool. Well, then that brings me to the next thing, which is property rights and all of the sort of infrastructure and the legal frameworks that we enjoy here on Earth, relative to mining, because in a way it's mining. It's not quite so mature in space, is it? What do we need to be able to extract a resource, keep it, and sell it?
Yeah, that is. So it's funny, when you think about it, it seems like that would be the most complex thing, but it's actually the thing that's been taken care of. Our friends at Planetary Resources back in 2015 led the way in getting the Space Resources Act signed into law, which says that any U.S. flagged company can go to another planet, extract a resource, and own it, bring it back to Earth, and sell it. And that is in the U.S. law, and there's similar laws around in a few other countries around the world. We don't. There is no claim regime. We can't claim to own the land, but once we extract the resource, we can claim it, own it, and sell it. And so we feel very comfortable about that. There's mission review processes through the U.S. government for sending a spacecraft to the moon. We'll follow that process. We've already been talking with the regulatory authorities, and clearly, my team, we have experience in doing that from our time at Blue Origin, spaceflight, Rocket Lab, and other companies. So that is really, we feel comfortable with where we are on that one. So feel good about that.
Yeah, and I agree with you, and I think it's a great example of the U.S. taking leadership, because for a number of years, we just kind of spun on this because we had, I'll call it an incomplete treaty regime.
Mm-hmm.
And, generating a new multinational agreement evaded us. And so I think the U.S. decided, well, let's go first and be reasonable and show the way that others can copy and pattern. The one other thing, though, I'll ask you about is that exists in mining law here on Earth terrestrially. There are claims, and you don't always own the land in a claim, but you own the right to exclusively develop it for some length of time or under some conditions. So, are we worried about going to the moon and investing a bunch of money to find the densest concentration of helium 3 and building our mechanical or thermal extraction system and then having other people just wait until we do that and then jump in there and capitalize on our prospecting?
Yeah, there is a fairly long lead time involved in developing something like this and getting something for the moon. Somebody has to go first. And if we don't, we meaning the U.S. I mean, I hope it's Interloon, and I think it will be given where we are. But the Chinese, if we don't, the Chinese will, and they don't think the same way about claims as we do. um, so,
Yes, I
so
think their neighbors could attest to that.
yeah, so there is this is important, not just for Interloon but for the country as well.
Yeah, I think so too. It isn't necessarily distributed evenly, and I think about an experience I had that you don't know about, where I was briefly involved in sea bottom mining for rare earth metals, manganese nodules, that sort of thing. And we had invested effort a few decades back in identifying where the resources were. And here on Earth, there's a legal framework around those types of resources where they must be shared proportionately with developing countries. And the sharing takes the form of which parts of the ocean floor are available and which are exclusive. And knowing where the stuff is a big business advantage, because when you share, you might want to reserve the richest deposits for yourself. And so it matters. And I think the thing that's probably different that you really touched on, Rob, that's fascinating is, and absolutely right, by the way, is the barrier to the actual operation of extraction is quite a bit higher. You're not going to just, like Howard Hughes was doing with the Glomar Explorer, scoop stuff off the bottom and have it. When we talk about doing this on the moon, there's a big lead time to put that infrastructure in place.
That's right.
And so that's a great point.
Mm-hmm.
So having said that, do you see a role for the government as part of this, or is it exclusively private industry?
Well, I think that any time you're doing something in space, it's really important to have the government on board and as a partner. First off, there's the regulatory effort, so the government's going to be involved in that. But going more to sort of let's say the science and exploration, and then we'll get into social and economic benefit. So certainly a commercial company can partner with NASA to help. What is it that NASA does? Like, NASA develops technology, explores the frontier, inspires people across all countries, and a program that takes 10 years to get to the moon and put astronauts out there, it's hard to keep people engaged. But having robotic missions that are interim missions, we have a mission called Prospect Moon that'll fly to the moon as early as late 2027, where we'll scoop and sample regolith, and we'll demonstrate our process, demonstrate that we can use a mechanical process to extract the helium-3. That's a mission that can fit on a CLPS-sized lander, and CLPS being NASA's Commercial Lunar Payload Services program. 4 of those 6 landers I mentioned are developed under the CLPS program. that can inspire people. It can, going to the moon and doing something, building a landing pad or extracting resources, that can really inspire people about what kind of future, we're going to have. And I think that's really important. So, you can kind of think of a mission that is, a commercial company partnered with NASA to go do something that's got both technological benefits and inspirational benefits. And oh, by the way, there's also science benefits as well. So,
Yeah, yeah.
and we have a chief scientist, Elizabeth Frank, who leads our efforts, and she works very closely with Harrison Schmidt. And there's a lot of important things to learn from operating on the moon, not just at the South Pole, in the equator, near in and
Sure.
around the Apollo landing sites. So that's the science and exploration. There is also the social. You blend that in with the social and economic benefit. We're obviously a commercial company that's got hundreds of millions in contracts to sell future helium-3. We want to make money. We want to grow. We want to be your rocket propellant provider 15 years down the
Hmm.
road. And it's not just about helium-3 for us. We want to help to build the in-space economy. So that's going to have huge benefits beyond that NASA can benefit from, and the whole space industry can benefit from.
Yeah, and I think of that as just one of the great powers of our system that we can have this kind of partnership between innovative private companies and commercial markets like yours
Hmm.
and a government entity like NASA that is able to do a couple of things nobody else can do in space, right? And it's more than just the tremendous breadth and depth technologically of NASA. It's their mission. They can do science because science is interesting. They can develop science that enables private business where the time scale of what they're doing doesn't close a business case. So, a lot of people forget there's a time value when it's you and me trying to make a business work. We can't just show that it'll create wealth a century from now, right? It's got to do it a lot sooner than that. But NASA is able to transcend some of these things and then give us the tools to go out and do what you just described. And I want to pause on one of the things you touched on too, the social and inspirational benefits. This is a different kind of space, for you and me and for the regular folks in the world. It's a great democratization in a way. We're always going to have the elite astronauts pushing the boundaries and exploring, but behind them, need to come the farmers and the settlers and the miners and ordinary people who will go to the moon and work for your company and extract natural resources because it's their job. What
Yeah,
an exciting prospect.
yeah, it really is. Thinking about that future, it's gets me out of bed every morning, and that really excites me. We talked about NASA, but there's other branches of the government that are very interested in this and what we're doing. The helium-3 stockpile is managed by the DOE isotope program.
Yep.
We, of course, have a contract with them, and they've been a great supporter of ours. We've received grants from that DOE group, as well as NASA, the NSF, and the Air Force. We've also gotten a grant from the state of Texas, so not just federal government, but the state government. And
Really?
earlier I talked about these regolith simulants. The grant we got from the state of Texas is to create a center next to the Johnson Space Center to make novel simulants. Most of the simulants that you can buy are particle size distribution,
Yeah.
material like metal distribution, but they don't. For example, they don't simulate solar wind implantation. They don't simulate electrostatics. They don't simulate other things. So we have started to hire a team. We've hired our first two employees down in Houston, and we're building that up, backed by the state of Texas and their visionary, Texas Space Commission.
That's really cool. And I'm glad you kind of touched on that as well because, I think a lot of our listeners might imagine regolith as, sand or
Yeah.
God forbid the word dirt. But it's not like that at all. It's very unique in terms of its properties. It's I don't know. I think of it as more like finely ground glass,
Yeah.
incredibly abrasive, some very very fine particulate, fine enough that when you get the highest quality simulates from a university, they're usually also carcinogens.
Right. Yeah. Yeah.
So when you talked about mechanical extraction, that means handling tons and tons of regolith,
Hmm.
and it's not like I said, it's not like mining sand here on Earth.
Right.
There must be very unique challenges with that.
Absolutely. The dust mitigation, developing seals joints that are going to hold up to that environment, but also just not fooling yourself into thinking that this sand can be this regolith can be easily simulated on Earth. We're going to do our best, but ultimately you're going to get to the moon, and you're going to have risk mitigations in place to figure out how to overcome the things that are going to get thrown in your way, all the wrenches that come your way. So that's space flight. That's doing hard things, and we've got built a team that's really geared up and ready to go attack that.
Do you imagine there's a significant, I'll call it human component to that? Are we just going to be able to send robots and they're going to deal with all the challenges that we run into that we didn't anticipate?
Yeah, that's we're planning to send robots. I think if we needed humans for this operation, the unit economics just don't even come close to closing. We're sending robots. We're taking advantage of all we know about planetary rovers and landers.
Sure.
The Apollo program, everything's been developed for Artemis, and then just a robotic maintenance program where designing a system that can easily be repaired and replaced inline, and that's how we're thinking about it.
So that's going to take more than a little bit of careful thought and testing and flexibility as we jump into it, huh?
Yeah, it sure will.
Well, I also, of course, look forward to when you're doing the extraction of water, which we can make into liquid oxygen and hydrogen because just like you enabled my Vulcan rocket, I'm planning on you enabling my through space transportation system we call ACES,
Hmm.
which doesn't work unless I can go buy propellant from you.
That's well, I'm looking forward to that, Tori. That's I think the deploying ACES, having a system that can be, you know, up and in the cislunar volume for long periods of time, that can be refueled. That's a game changer for the kind of things that we want to do as a nation and also within our industry as well. It's um, really really important.
So then I got to ask you maybe a question this way, Rob. So that's a beautiful vision, and it's also beautiful because it's practical and it's something I know we can do. But when you're laying awake at night thinking about how to do all of this, what's the thing you're stuck on that keeps you awake?
Well, I don't I have to raise the money to go do this. Um, so every step of the way, as a venture-backed company, you have to demonstrate progress every single step of the way. Um, Not that I haven't done that before, but you're relying on being able to tell that story, that big vision story, and find the right people that are willing to um, back you with tens of millions of dollars. So we've raised about $18 million to date. We're out in the market raising right now. Um, the um, when when you build a team, I mean, being able to pay them, it does keep me up, at night because they're great people. They all left great jobs to come work at Interloon and help us make this big vision a reality. So that's what I focus on. And I've learned, that's the one part of being an executive, a CEO that I didn't get to learn at my prior job, um, and I'm really excited by it because I've spent 7 years making the connections with financial institutions, the venture capitalists, and a whole network of startup founders that we all work together and we've got each other's backs. So I really enjoy that part of it.
Yeah, heavy responsibility, but you know, Rob, if anybody can do it, you can.
Thanks, Tori. I appreciate having your backing and your friendship and support over the years. So thank you.
Oh, you bet. All right, I'm getting the high sign, so we're going to have to switch to the lightning round. Are you ready?
I am ready. Yeah.
All right, we always start with this one: Kirk or Spock?
Spock. I'm a logic person, like to focus on logic. So, yeah.
Absolutely, no surprise there. We're going to stick with the theme of entertainment for a minute. The TV show For All Mankind, or let's see if you're old enough to remember Space 1999.
Oh boy, I do remember Space 1999. But I gotta say, I loved For All Mankind. I think it was a really amazing show, not just because of the helium-3 thread, but I love the scene where the senator says, "Madam President, we can do this if we can access NASA's $75 billion budget surplus."
Yes, well, it is fiction.
Oh my! Someday we can hope.
Yep,
Yeah.
I love that one too. All right, next one. You've probably already answered this one, but I'm going to ask it anyway. Water or helium-3?
I can I say both? Um,
Yes, you can. You
we're-
say anything you want, Rob.
Helium-3 is the ideal go-to-market, and we're so committed to securing that supply chain. But ultimately, water is going to make the space industry go. We can make rocket propellant, we can make all kinds of things, and we want to be in a place where we can access that and harvest that as well.
Yeah, they're intertwined in a way, I think.
They sure are. Yeah.
Yeah. All right, you're a rocket engine developer. We touched on that briefly for those who don't know all about your background, just know you through Interlude. So I got to ask you, RD 180 or BE4?
I am going with the BE4. Got to name it. Got to partner with you. Got to build that initial team and select that Huntsville site. And I'm just so proud of the progress that Blue's made on that. And you know, everything is done incrementally over time, and
Mm-hmm.
the BE4 performance is just going to get better and better over time. So
Yes, it is. Yep, I agree. I mean, the RD 180 was a great workhorse. It was something important to the State Department, so it had that dimension to it.
mhm.
But the BE4 is the real enabler of our future.
Yeah,
Yeah.
yeah.
All right. Sea of Tranquility or Shackleton Crater?
I'm going to go with Sea of Tranquility. There is science and exploration reasons to go to Shackleton, go to the South Pole, and I think that is a NASA thing. That's a thing for nations. But helium-3, what we're doing, there's plenty of helium-3 in the equatorial near side of the moon, and that's where we're focused on.
Yep, I think so too. It's hard not to love them both, though.
No, no, want to get to them both in my time. So I've got a few years left in the career, and I want to make sure that we're out exploring every area.
Yep, me too. Awesome. All right. So, Heinz London, the inventor of dilution refrigeration that you talked about for quantum,
Mhm.
or Mark Oliphant, who discovered helium-3 in tritium?
I am going to go with Mark Oliphant. He's an Australian,
Yes.
and we have Nina Hooper is one of our team members based in Sydney, Australia, and so in honor of Nina, I'm going to select Mark Oliphant.
That's awesome. Great pick.
Yeah.
Yeah, I like them both, but I kind of like Oliphant better too. I mean, that was really cool. All right, well, we're kind of out of time. Rob, thank you so much for joining me and joining our listeners.
Well, thank you, Tori. And I just really honored to be on the show and follow some great friends like Thomas Erbukin and Nina Armagno,
Yeah.
Jim Bridenstine, and so thanks for having me on.
Of course, maybe we'll do it again sometime. We hardly touched on your illustrious career. A lot of our listeners don't realize, the deep background you have. So maybe we'll have another chat sometime.
I'd like that. Great to see you, Tori. Thanks again.
Likewise. All right, bye-bye, and thank you all for tuning in to the Burn Sequence.
Burn sequence.